Today we will discuss about BERT, which is BERT, which is a popular language processing model. Let's assume you are working on a text classification task where the input to the model is a word and you need to identify whether the input to the model is a person or country. For example, the input word is Dhoni, who is a person. The way the model classifies the words is by capturing the similarity between two words or creating a vector. To do so, we need to focus on the features of both elements. The features of Dhoni would be person, question mark, which means whether he is a person, healthy, location, has two eyes, has government, etc. Using this, the feature of Australia and Dhoni would be very different, and the features of Dhoni and some other player will be very similar. Using these features and converting them to vectors, and then we will compare them using our model. You can understand the similarities and differences between the two models. One of the ways you can generate the word embeddings is by using word2vec. In the real world cases, the models can take the features by itself and the features do not need to be handpicked. But suppose you are speaking about a word which could have two meanings based on context. He didn't receive fair treatment versus fun fair in New York City this summer. In this case, both words are fair, but meanings are very different. While at one place fair means just, and the other it means a place where you can go to have fun. So you need a model which can generate contextualized meaning from a word. So you need to look at the whole sentence and generate the number representation for this word. And BERT allows you to generate contextualized embedding. It can also understand similarities between words. BERT can also generate the embedding for an entire sentence. Usually, BERT will generate a vector of size 768. BERT was trained by Google on 2500 million words on Wikipedia and 800 million words on different books. So they used mass language model to mask 15% of the words, which means simply to hide or mask take away 15% of the words, and then they would generate training samples where the missing word was also included to train the BERT model to predict the words from the statement and thus achieve the word embeddings. They also used next sentence prediction where the model predicts the next statement based on the given statement. Even the search engine in Google uses BERT. The full form of BERT is bidirectional encoder representations from transformers. Let's code BERT in Python. Let's first import the necessary libraries. Import TensorFlow underscore hub as hub and import TensorFlow underscore text as text. Now let's create variables for our URLs. So preprocess underscore URL equals the variable for the link for that, and code underscore URL equals the link for that. Now let's create our hub layers and pass in our URL. So BERT underscore preprocess underscore model equals hub.keras layer preprocess underscore URL. Now let's provide some text, some random text. So text underscore test equals nice movie indeed, I love Python programming. Text underscore preprocessed equals BERT underscore preprocess underscore model text underscore test text underscore preprocessed dot keys. In this we are simply getting the mask or the embedding for the sentences. Now let's create another layer, and this layer will have encoder URL. Now let's generate our sentence or word embedding and store it in an object or dictionary, and we will see the keys of our dictionary which will contain the embeddings. BERT underscore model equals hub.keras layer encoder underscore URL. BERT underscore results equals BERT underscore model text underscore preprocessed. BERT underscore results dot keys. Pooled output will be the meaning of the entire sentence, and sequence output is the individual word embedding. So BERT underscore results encoder output. Encoder output is the encoder output of all 12 layers, and the last one is the same as sequence output.